Hey guys, HardlyBriefDan here with another episode of our August game of the month, Cannon and Assault, and today we're going to continue where we left off with working on our cannon movement and cannon firing. So, to recap what we did last time is we did some artwork. We created a background, a ground, and a cannon transform for our game. It's all temporary probably for now. Hopefully you guys learned something how to use Inkscape and learned a little bit of programming. We ended the last video where we were doing our cannon control, where we actually added the ability to move the cannon left and right, and we also added firing. So the game knew, like in console, the game knew that when you're actually hitting the left button to fire, which is great. This is what we want. We're making progress on our game, but we're not done yet. What we need to do is add limits to the cannon, and we need to start seeing how we're going to fire the cannon. So what we're going to do today is add limits and then talk about some Raycast and stuff. So hopefully you guys enjoy it. Hopefully you learned something. So right now we're going to jump into our cannon mouse control script that's in MonoDevelop. I'm going to open that up. As you see, we have three if statements. We have our left. If our left mouse button is being pressed, we're going to fire. And then if we're moving the mouse left or right, we're going to move left or right. Now, what we're going to start off doing first is limits. We're going to go ahead and create two private floats. Private float, we're going to call it left limit, and we're going to do a private float, and we're going to do right limit. We're going to actually go ahead and make a private int speed for now. Actually, we're going to make that public because, just a tip, if you're using arrow keys to move around, if you hold Control and Shift, you can select an entire word. Little tip to move around faster, you can select different things to copy and paste. But anyways, we're going to do speed. We're going to use speed a little later. But for right now, we're doing our left and right limit. We're going to set these equal to 0. Actually, set these equal to 0.4 for the left one, F. You need an F in for float in C#. F again. We're going to make the right limit negative 0.04 or 0.4, and I'm going to explain that in a minute. But basically, come down to where we're moving right. We're moving when our left mouse, or when the x-axis sees that we're greater than 0, then we're moving the cannon to the right. But what we want to do is check to see where that cannon is, and then if we're at a certain point, our limit, our right limit in this case, we don't want to move anymore. So we're going to create an if statement. We're going to go if our transform dot rotation. So this is looking at the rotation that you see in the inspector. And we're going to say if it's greater than our right limit, then we're going to allow movement. But if it's not, we don't want to allow movement. And I'm going to show you once I create these if statements what it's doing. So we're going to go transform form.rotation, and we're going to do is less than our left limit this time. Go ahead and delete that one. Okay, we're going to jump down here, do a bracket. Okay, so now we have our if statements. We're saying if we're greater than our right limit, we're going to allow us to move. If we're less than our left limit, we'll allow us to move. Controls to save, jump into Unity, and it should work. We got an error. Can't be applied to. Rotation.z. Excuse me. So we'll put .z. Basically, if you're looking at rotation, you're comparing a vector 3 to a float, which we don't want to do. We want to compare our rotation, our z value, the z-axis value versus our float. So Control Z or Control S, excuse me, to save. Jump back into Unity. It should get rid of our errors. Gonna go ahead and press play, and as you see, we can't rotate any farther, which is perfect. This is what we want. It's stopping the cannon movement from going all the way around. Now the next thing we're gonna add, basically, we just add like invisible barriers. Not really, but I mean stopping it by script, but you can imagine that there's being just little blocks here that stop it. But now we're going to jump in and do some firing from the cannon. Oh, actually, I want to go ahead. This speed variable, I'm going to throw in here so that you guys can change the speed of your cannon if you want. So I know last time I was talking about, I wasn't sure if I wanted to do this, and I thought I'd just throw it in there. I'm going to set it equal to 1 so it doesn't change anything because it's just multiplying it. But you can go ahead and change that in the inspector and kind of mess around with speed, see where you want your cannon speed at. I might adjust that later, but I just wanted to give you the option instead of not having it. But now what we want to do is, I said, go into firing the cannon. And I'm going to discuss a few things. Some of them we don't need for this game, but I think they're pretty cool, and you can use them in your other projects that you might be working on along with this project. And the two things is we're going to do screen to world point coordinates, which is perfect for RTSs, and basically converting your mouse X and Y coordinates to in-game coordinates versus just pixel coordinates. The other thing we're going to do is talk about Raycast. And I'm going to do a 2D Raycast. The 3D Raycast is basically the same idea, but instead of using vector 2s like the 2D one, we're going to use vector 3s for 3D one. But we're going to stick to 2D because this is a 2D game. So, that was long-winded, but we're going to jump right in. The first thing we're going to do is create a private variable, and it's going to be a transform, and we're going to call it firing point. Now you're like, what is this firing point? Well, Controls to save. I'm going to jump into Unity, and you can see I have this game object here. It's called firing point. And what I did, go in our scene view, you can see it's this object here. Well, I'm going to actually delete it and show you from the start. So what we're going to do is go to game object. You're going to create an empty game object. And it's right here in the hierarchy. You can see it. We're going to go ahead and name this firing point. Goodness, firing point. So there we go. Firing point. Going to go ahead and click it. I didn't save it. Shoot. There we go. So now we have our firing point. I'm going to go ahead and use these two arrows, the X and Y arrows, and I'm going to try to center it as best I can on our cannon. Doesn't have to be perfect, but it has to look, decent. Sorry for the noise in the background. But anyways, now we have this game object here. You might be wondering what it's for. Well, this is where we're going to be firing things out of our cannon. This is so we have a central location wherever we're turning. Instead of firing straight from the bottom, we're going to fire from this little point. So go ahead and drag this firing point to our cannon base. Should light up. And now what we just did here, doing that, it creates this cannon is the parent, and the firing point is a child. So the parent of our firing point is the cannon. Now, go ahead and click on our firing point in the hierarchy and go to tag. And we're going to create a tag. I've already created it, but I'm going to show you how to do it. So tags are used, you can find game objects, to tag game objects, to find them real fast in script and stuff. And what we're going to do is tag this firing point as a custom firing point. If you haven't made a tag yet, you won't see this in here, and I'm going to show you how. Go ahead and click Add Tag, and you see this size, and your size should probably say 1, but I went ahead and made it 20, and basically it just creates this giant array of elements that you can have tags, and allows you to create custom tags. So I went ahead and made one called firing point, and you can go back into, once you create it, to hit enter. Oh, I just erased it. You go ahead and rewrite it. Firing point. Jump back into firing point, or jump back in the hierarchy and click firing point. And now in the tag, you should be able to see the tag you just created. Maybe you labeled it differently. Maybe like missile spawn or something. I'm not sure. But now we have a firing point. And the control is to save. Looks like we have an error here. Control, it should have gone away. Let's run it and see if we have any issues. We don't. We're still firing, which is good. That's weird. The speed has seemed to this me adding the speed variable. Let me see what it put it at. I made it. Oh, that's why, because it's in public. It's set at 1. There we go. Okay, what I just did there, if you added that speed variable, since I made it public, it was set initially to 0 in the inspector, so I wouldn't change it to 1 so that we had some speed for the cannon to move. But anyways, jump back into Unity, or I guess in MonoDevelop. I'm zooming out in Unity just so we can see some stuff. But jump back into Unity, or MonoDevelop, excuse me. And now what we need to do is, we have this firing point transform variable, and we need to assign it something. So we're going to go firing point. We're going to set it equal to a game object. Use capital game object, capital G, capital O. Dot find game object. Don't use game objects. You want the game object singular. And the tag is firing point. That's a tag that we just created. And then you're going to do dot transform. Oh, not comma. Dot transform. And then semicolon. And basically what this does is it finds in our game, it finds some object with a tag firing point, which it finds our firing point, which is the empty game object we just created. Pretty simple. So now that we have that, we're going to go down in our left mouse button here, and we're going to create a Raycast. So what you want to do is go Raycast, hit, it's going to be a 2D hit actually, because we're using 2D. Raycast, we're going to call it hit. We're not probably going to use this whole function, but I'll jump in a second. So we're going to do physics 2D, since we're in the 2D Unity. We're going to do a Raycast. And as you see, it takes 2 vector 2s. It takes an origin, and it takes a direction. And the direction, or the origin, is going to be our firing point's position. And then it's going to take the direction, and we're just going to do firing point dot up. And what this means is that we're just going to fire this ray, this imaginary line, if you will. This ray, we're just going to fire straight out from the cannon, or in the up direction. So what a Raycast is, or what it's used for, is to fire a line, an imaginary line. You won't be able to see. We're going to make it so you can see it, but it's going to fire an imaginary line that allows, that sees if it hits anything, intersects anything, and if it hits something, it's going to be registered in this hit variable that we created right here. So like I said, so we're firing a line out. It's going to look to see if you have a hit variable, or see if it hits a collider of some sort, and if it does, it's going to tell you that it did that. But we're not using the hit yet. We're just going to fire a line. I want to show you kind of where so we can use it to show where the projectiles are going to go. So to show this Raycast, we're going to use a debug.draw line. And this takes 3 variables. It takes a vector start, an end, and then it takes a color, or we can add a color to it. So we're going to do our game object's position. So we're going to go firing point.position. We're going to do this we're going to create a new vector. And we're going to create a vector 2. Now it says it takes a vector 3, but we're just going to go ahead and use a vector 2. Firing point dot, it's firing point. I'm going to go ahead and just copy this. Firing point dot up dot x, and then we're going to go firing point dot up dot y. And then it's going to take a color, so you do color dot, and you can use any color you want. I'm going to go ahead and use red. I think it shows up well. Control S to save. And basically what this line of code does is it shoots out a line again from our same position, from our vector position up, or vector point up, firing point up. So this new vector 2 does, and it just colors it. And this is going to allow us to see something firing out of the cannon. So go ahead and into Unity. We don't have any errors. I'm going to go ahead and press play, and when I slam the left mouse button, we're getting it, but it's rotating oddly. And that's because I'm actually using the wrong thing. We want to be drawing a ray and not a line. There we go. So the thing between draw a ray and draw a line, I should have caught that. Sorry. Draw a ray shoots it in a direction. Draw a line shoots it between 2 points. So a line draws a line from point A to point B. Or draw a ray draws a line from point A in a direction of point B. So Control to save, go into Unity, and now you can see, hopefully, we have our line. So when I slam on the left mouse button, I'm going to go ahead and zoom in. You're going to see this line fire. Hopefully it shows up on the screen, but you see a line coming out. It's super fast because it's updating every frame because we're firing every frame. But you see the lines firing where we want it, and it's firing in the direction. And this allows us, like I said, to kind of see where our projectiles are going to go. And what I'm thinking I might do, I'm not sure yet. I think, so what, for instance, in a lot of MMOs, let's use World of Warcraft for example. If you've ever played a caster in an MMO and RPG, usually they use, same with Call of Duty. That's a better, more popular game. Call of Duty, Battlefield, World of Warcraft, any of these games where you fire a projectile, they use rays. And basically, if it sets a path for something to follow. So, for instance, let's say we have a helicopter, because that's one of our designs, was a helicopter comes in here, right? So let's say my cursor is a helicopter. We fire the cannon at it. The ray, let's say the ray, and the Raycast hits it. We've created we found a target for one, and that target, since the ray hit something, we can say, okay, well, let's use a hit's position, which will be that target, and we're going to follow, or that we can set the projectile path to wherever that target is. So it kind of takes the judging out of it, which I don't think I want to do, but that's how those games work. So let me think. I'll try to explain this in the simplest terms I can. In Call of Duty, when you... sorry about that. Anyways, we have, let's say in Call of Duty you have a firing point, or you're shooting your gun, and it's as soon as you trigger, as soon as you hit the left mouse button to fire that gun in Call of Duty, a Raycast shoots out of the gun. Most likely, this is how most of them work. A Raycast will shoot out of the gun. It's going to see if you hit something. If you hit something, good. It's going to calculate damage. That bullet that you see in game is just for looks. That's not what's calculating damage. It's calculating damage based on seeing if that Raycast hit. Or we can use a Raycast for spells like in World of Warcraft, for example, where you cast... Oh, that's a bad example because it doesn't follow the Raycast. Alright, scratch the whole World of Warcraft thing. Firing. In a Battlefield game, Call of Duty, you shoot the gun. Damage and stuff is calculated based on a Raycast. The animation of the bullet comes way later. Or the projectile fire. It's like, they do it all on the Raycast, because the Raycast is instant. I don't know what's going on right now. Sorry about that. Sorry about that error. But anyways, the Raycast fires out of the gun. See if it hits something. If it hits a player, if tagged as player, then it calculates damage, and then it simulates the bullet. So what I could do is, using the Raycast, we could fire the Raycast towards whatever object out of the cannon. If it hits a helicopter, plane, a missile, then we can count it as a hit. But I don't want to do that, I don't think. I think I want to use the projectile, have projectile target hitting instead, because it'll look like the cannon will have delays in it, and we don't want that. So don't worry about the raycasting. I think it's good to learn what a raycast is, and it's going to help us debug stuff in the future. That's why we really wanted to cover it. But anyways, we're going to jump in. We're going to move on to one other thing I wanted to cover in this video. Basically, what I wanted to cover was screen point, world coordinates for the camera and your mouse. So, when you look at your mouse coordinates, I'm going to go ahead and make a debug statement and show you. So let's say you're working on RTS, and you want to use your mouse input and get a exact position where your mouse is. Well, what you can do is do input.mouse position, and then do that in debug statement. Controls to save. Jump into Unity. Go ahead and press play. In our console view, you can see where my mouse position is. And these are pixel coordinates. So my screen's big. So, you know, I got 1080, 1920, 1080p screen, so it's going to look up all the pixel values. And we don't want that. We want the world coordinates. So what you do to get the world coordinates to see where your mouse is in your game world, which I said is perfect for an RTS, you use what they call a screen to world point, and it uses your main camera. So in our update function, I'm going to go ahead and show you this. If we do a vector 3 or vector 2, depending, you know, do vector 3. It takes a vector 3 actually. So do vector 3. We're going to call it point. We're going to set that equal to a camera dot main. So this is our main camera that starts off in every scene. You might have a different one if you change it. And then do that screen to world coordinates or world point. And this takes a vector 3. So we're going to go ahead and do a new vector 3. And the first one's going to be input dot mouse position dot x. And then we're going to do input dot mouse position dot y and then 0. Now, if you're doing a 3D RTS, this is you can just do screen to world point input dot mouse position. However, since I'm doing a Unity 2D game, I'm showing you guys the 2D way. So instead of this mouse position, this debug statement, I'm going to go ahead and erase it. We're going to jump down below our vector 3 that we just created. Do debug.log, and we're going to output point. So this is going to show us the vector 3 that we get, and it should be our mouse coordinates. Should be x, y, and then 0, and then it's going to be to the screen point, to the world point. So it's going to show you our world coordinates versus our pixel coordinates. Control S to save. To go into Unity, going to go ahead and press play, and now you see our values are much, much better. They're what we want. We're still firing, but we're getting where we are in the world. And like I said, this is what you're gonna want to use that function. Since we're doing Raycast and stuff, I thought it'd be quick and easy just to show you how to get this, because I know I've gotten a couple comments where people are saying, "Can you do RTS?" I probably won't do RTS for a while. They're pretty complicated, but this is one way you can get the mouse movement down. But anyways, so today we added a Raycast that shows where we're firing from. We added our limits for our the rotation of the camera, and we added we're drawing the Raycast, and then we're adding this. When we added this camera viewpoint thing, just to show you how that works. We covered tagging, game object tagging, and how to add your own custom tags in the inspector, and we covered parenting and parents and childs. So in the next video, we're actually going to start firing projectiles. I'll probably make a quick video of showing maybe some of the projectiles I fire in me creating some of the projectiles in Inkscape. I'll probably do like maybe a quick video of that, and then we'll jump into actually firing. Anyways, if you liked the video, if you learned something, please like, subscribe, comment, share with all your friends and your family, pass on the word. Thanks for all the support, and I'll talk to you guys next time.